So this is the graph of x squared minus 8x plus 7, and I want to know when this graph is greater than or equal to 0. So if I'm looking for where this piece is greater than or equal to 0, am I looking at the part that's above the x-axis or below the x-axis? Above, because anything above the x-axis is going to be positive. And if I wanted to be like even more specific, just to kind of give you a reference, if I'm looking for what's greater than or equal to 0, am I looking in what quadrants am I looking at? 1 and 2. So quadrants 1 and 2 would be anything greater than 0. So for this problem, I'm looking at the graph as it exists in those two quadrants, which would be everything above the x-axis or all of the stuff that's shaded in blue. Well, when you look at that, is one piece of the graph above the quadratic or above the x-axis, or two pieces of the graph? Two. So when we're trying to figure out when this graph is above the x-axis, we're figuring out what those two pieces are. When we think about our x-axis, just numerically, if we extend it out all the way, then it starts at negative infinity. So there would be a negative infinity over here. And if we extended it to the right, then at the right side, we would have a positive infinity. There we go. So if I extended this out to the right, I would have a positive infinity. So if I'm trying to figure out what intervals it's positive, I'm looking again for what's above the x-axis. Well, the first time it goes above the x-axis is here. Or sorry, the piece that's above the x-axis is this part. Well, where does that part start at? If I think I'm starting, I go to the far left. So it starts at negative infinity and it goes to what value? 1. So the first interval where it's positive is from negative infinity is less than x, which is less than or equal to 1. And then the second interval that it's positive is on the other side of the graph. So I'm looking over here. That starts at 7 and it goes to what? Infinity. Positive infinity. Because that part is above the x-axis. So that would be 7 is less than or equal to x, which is less than positive infinity. And no, you don't have to write that positive sign. I just try and write it so we're distinguishing between positive and negative infinity. So, okay. So if I'm looking for the same graph now, but it's looking to be less than 0, which quadrants am I looking in this time? 3 and 4. I'm looking for the ones on the bottom side of the x-axis. So that would be all of this area down here. Well, is that one piece of the graph or two pieces of the graph? That's one piece. Yeah, that's just one piece of the graph. So everything down here, all of my y values are negative in this area, and that's what less than 0 means. Well, where does that start at? What value does that begin at? At 1, and it ends over here at 7. So my interval would be 1 is less than x, which is less than 7. So why on this question did I just use less than symbols, but on the previous question I used greater than or equal to symbols? So it goes back to what the problem said. The problem said I wanted to be less than 0 and just less than 0. If it had said less than or equal to 0, then I would have used less than or equal to symbols here. Because at 1, when x is 1, what is y? 0. So at this point, I don't want it to be equal to 0. I just want what is less than 0, and that's it. Let's look at problem 6 on page 223. Okay, let's look at problem 6 on page 223. So I have x squared minus 6x plus 10 is greater than or equal to 0. So, greater than or equal to 2, I apologize. What is the very first thing I need to do here? I need to subtract the 2 because I need to get that to equal 0. So I end up with x squared minus 6x plus 8 is greater than or equal to 0. So I need to find my x-intercepts. I have to find my x-intercepts because my x-intercepts are my distinguishing points. That's what splits my graph into the three pieces, the parts that are above and the parts that are below the x-axis. So if I'm going to factor this, I need to list my factor table out. So my factor table is going to give me 8 on the left side, negative 6 on the right side. So my numbers would be negative 4 and negative 2. And we learned yesterday that if I have a 1 as my leading coefficient, then I can skip all the steps of factoring and just go to x minus 4 and x plus 2. And that would be, again, greater than or equal to 0.
So x is positive 4 and positive 2.
Yeah, so again, there was an error, so it wasn't x minus 2, I'm sorry, it was x plus 2. And so my x-intercepts then would be, my first x-intercept would be, or one of my x-intercepts would be positive 4, the other x-intercept would be positive 2.
Oh, never mind. I kind of lied and got tripped up earlier.
It's okay. So when they, like, remember they switched signs. And the reason they're switching signs, like I'm not making this up, is because when I'm getting rid of my x, to find the x-intercept, I'm setting x minus 4 equal to 0, and then I'm adding 4 to both sides. And 0 plus 4 is going to give me that positive 4. And then to get x minus 2 equal to 0, I am adding 2 to both sides, and I'm going to get x equals positive 2.
When you wrote 4, it looked like a Y. I was like, why'd you write a Y?
Oh, sorry, that is a 4 there. So those are my two x-intercepts, and those matter because those are the points that I'm concerned with when I look at my graph. So when I draw my graphs, just to help me out, I'm not even going to use my y-axis because my y-axis has no bearing on this problem. The only thing I'm concerned about is where is this graph above the x-axis and where is this graph below the x-axis. So if I know my graph starts at negative infinity, it goes out here to positive infinity, and I have points at positive 2 and positive 4. So when I sketch my graph, is this parabola going to open up or is this parabola going to open down? Up. And what is it that makes it open up? Yes, because a, my number in front of x squared, is a positive 1. So I'm going to draw my graph, which looks something like this. Is this 100% accurate? No, but I don't really care about the y-axis because the only thing I'm looking at is where is this graph in relation to the x-axis? Is it above it or is it below it? That's the part I'm worried about. So for our problem that we're doing, if we want the pieces that are greater than or equal to 0, are we looking at what's above the x-axis or below the x-axis? Above, so I'm looking at all of this up here. Well, how many answers am I going to have? 1 or 2? 2, because there's 2 distinct pieces that are above the x-axis. So this first piece that's above the x-axis, where does it start at? Negative infinity. So it goes from negative infinity is less than x, which is less than or equal to 2. And why is it in this case less than or equal to? Okay. What did you say, Fatima? It's a set point, and because at the top in our original problem it said that it wanted what was less than or equal to. Up here it had that equal to symbol, so that's what we knew we were using. Why at negative infinity do I just use a less than?
Because it can't be equal to infinity.
Yes, infinity is always just less than because we can't actually like equal infinity. It's a concept, not like a specific number. So then the other side of my graph that's also above the x-axis, where does that part start? 4, which is x, which is less than infinity. So I'm going to give you another problem that I want you to do because I want to give you one that you're going to factor. So I'm going to write this over here to the side because I have space. Just so you know, these are the last 2 problems I'm going to do from the notes. So anywhere in the notes that you have space, you can write this. On this page, a different page. I am doing problem 7 on this page. But anywhere else that you have room, you're welcome to write that. All right. So your problem was x squared minus 7x plus 10. And everything I checked, well, you got at least portions of it right. So y'all knew that your x-intercepts ended up being 2 and 5 because when this factored, it was x minus 2 times x minus 5. And then we set each of those equal to 0. And I think everybody that I saw got that 2 and that 5 correct. There was some question on which way the graph opens. So remember, the graph opens depending on what the number in front of x squared is. The number in front of x squared in this case is a positive 1. So my graph is going to open up. So it's going to look like this. The biggest issue that I saw is understanding which half of the graph, which portion of the graph I'm looking for. So I wanted what was less than or equal to 0. If it's less than or equal to 0, is it above the x-axis or below the x-axis? Below. So I am looking at this portion of the graph. For this portion of the graph, where does that portion start at? 2. And it's going to be less than or equal to x, which is less than or equal to 5, because that's where that portion starts and stops. Okay? Because I'm only looking at that little bitty piece of it. And I had a question earlier of does it matter which way you write the numbers? And the answer to that question was just write them in numerical order. So anytime you're ever trying to figure out how to write your interval, like what number comes first, write them in numerical order. Okay? As long as you do that, you're going to be good. I don't on this one because the negative infinity and positive infinity is when the graph is above the x-axis. So this piece right here from negative infinity to 2, all of my y values are positive because that graph's above the x-axis. From 5 to infinity, same thing. That graph is above the x-axis, so it's positive. So I'm not looking at these two pieces. I'm looking at this piece that's down here, just the part that's below the x-axis. Okay? Problem 7 says 3x squared is less than 3x plus 2. So what's the first thing I need to do? Subtract 3x and subtract 2. Okay. There was a question in my last class, and it was a great question about flipping the inequality sign. When do you flip the inequality sign? If you divide by a negative number. I don't think that you're going to have to do that in any problem, but I wouldn't want to say, no, you never flip the inequality sign, and then there's some problem where you have to divide by a negative number and you do. Okay? But I don't think there is. So I have 3x squared minus 3x minus 2 is less than 0. Can I factor that? I cannot. So I have to use what? Quadratic formula or complete the square. I think most of you probably prefer quadratic formula. Yes. So if I'm going to do the quadratic formula, I have negative b plus or minus the square root of b squared minus 4ac all over 2a. And then I start plugging in stuff. What is b going to be in this problem? 3. And it says negative b, which really means it'll be positive 3 plus or minus the square root of squared minus 4 times negative 2 all over 2 times 3. So the first thing I'm going to find is what? The discriminant. It does give us 33. So we get 3 plus or minus the square root of 33 all over 6. Can I simplify the square root of 33 at all? No. Because its only factors are 3 and 11. There's no pairs there. So I have to leave it like this. So I know that I'm going to sketch my graph so I have a general idea of what this looks like. And I know that my x-intercepts are going to go on here.
So how do your x-intercepts are 3 and 6?
My x-intercepts are not 3 and 6. My x-intercepts are... The first one is 3, let's try that again, 3 plus the square root of 33 over 6. And my second one is 3 minus the square root of 33 over 6. Yes, so the entire thing. What is 3 plus the square root of 33 divided by 6? Say that again. 1.46 or 1.45. And then what is 3 minus the square root of 33 divided by 6? Okay. So I'm going to write these over here on my number line. I'm actually going to write them using my square roots because that's what I want to write my interval using. So why not? I just needed the decimals to know which one came first to ensure that I was doing that part right. So I have 3 minus the square root of 33 over 6 on the left side. And then on the right side, I have 3 plus the square root of 33 over 6. So now I'm going to sketch this graph. So which way is my graph going to open? Up. And how do you know it opens up? Because my a value is positive. Because this number right here is a positive 3. So I'm going to draw my graph opening up. And then I am looking for this problem, my inequality symbol is what is less than 0. So things that are less than 0, which portion of the graph am I looking at? The bottom portion. So I'm looking at the part that is less than 0. So that would be all of this down here. Well, if I'm trying to figure out what that portion is, I want to figure out where that portion starts and stops. So that yellow part of the graph that we see, where does it start at?
3 minus square root of 33.
It goes from 3 minus the square root of 33 over 6. Would it be less than or equal to? Less than. And why is it less than? That's what it asked for, was just less than 0, which shows less than x, which is less than again, and then it would be 3 plus the square root of 33 over 6. That would be your answer to this problem. That is the interval that is less than 0. So what that means is if my x value is any number between those two, between 3 minus the square root of 33 over 6 and 3 plus the square root of 33 over 6, if my x value is between those two, what do we know about our y value? It's going to be negative. So if my x is between those numbers, my y value is negative. If my x is not between those two numbers, that means my y value is positive.